Same type of deal for this next example. So we've got three equations here. We got x minus 3y plus z equals 1. We got 2x minus y minus 2z equals 2. And we got x plus 2y minus 3z equals negative 1. I'm just going to leave that first one alone. It's got all three variables in it. So let's see if we can get rid of the x's in the second one. So what I'm thinking is if we take that first row and multiply it by negative 2, so if we do negative 2 times row 1 and add that to row 2, that might help us clear out the x's. So we got x minus 3y plus z. Oh, scratch that. Sorry, did that wrong. Wasn't thinking. If we take that first row and multiply the whole thing by negative 2, we got negative 2x. Negative 3 times negative 2 is going to give us positive 6y. And then z times negative 2 is going to give us negative 2z. And we're going to multiply that 1 by negative 2, giving us negative 2. The second row, we're not changing anything. We're just adding it. So we got 2x minus y minus 2z equals 2. And we're going to add these together. So we end up with negative 2x plus 2x. Those cancel out. That's the whole point. So we end up with 0 x's. So 6y plus negative, and let me do a better job labeling this, plus negative y gives us 5y. Negative 2z plus negative 2z gives us negative 4z. And then negative 2 plus 2 gives us 0. So now we have an equation we can plug into the second slot. So we got x minus 3y plus z equals 1. That first row we're leaving alone. The second row we can now have 5y minus 4z equals, oh, sorry, that was horribly spaced. My apologies. Recommendation, I got sloppy with this. Keep your y's, your z's, your x's, keep those lined up. So we got 5y plus minus 4z equals 0. And then finally our last row is x plus 2y minus 3z equals negative 1. So we've got this set up where we still have all three variables in the first row. We've only got two variables in the second row. Now the last row we want it to get down to just one variable. So what I'm thinking here is let's add row 1 and row 2 together. Or sorry, let's add the opposite of row 1 and add it to row 2. So we're going to take the opposite of everything in row 1, and we're going to do negative x plus 3y minus z equals negative 1, and add it to row 3, which was x plus 2y minus 3z equals negative 1. So we're going to add these two rows together. Add them together. Negative x plus x is 0, so that cancels out. 3y plus 2y gives us 5y. Negative z plus negative 3z is negative 4z. And then we have negative 1 plus negative 1 equals negative 2. Okay, so now we've got it down to just two variables. So let's replace that last equation. So the first equation, we still haven't changed it. We got x minus 3y plus z equals 1. The second equation, we switched it with 5y minus 4z equals 0. And finally, our last equation, and we just got this, is 5y minus 4z equals 2. Right there, that we got right at the end there. So, looking at this, we'll look into the last two equations. We want to try to get rid of the y in the last equation. So what I'm thinking is we can do the opposite of row 2 and add it to row 3. So when we take the opposite of row 2, we got negative 5y plus 4z equals, well, negative 0 is still 0. Row 3 is 5y minus 4z equals 2. And again, we're adding these two lines together. And when we add negative 5y plus 5y, we get 0. When we add 4z plus negative 4z, we also get 0. That means that whole side simplifies to 0. Oh, also, sorry, I forgot a negative symbol in there. My apologies, that was negative 2. Not that it's going to make much of a difference. On the right side, we have 0 plus negative 2 gives us negative 2, which is just not true. 0 is not equal to negative 2. So we say this is false. And if we have a false statement, that means there are no solutions. So unfortunately, this is a case that we ended up with a good amount of work, and we end up finding no solutions. Now, if we end up with a system that has no solutions, we call it an inconsistent system. So we call it an inconsistent system. They do not intersect all at one point.